Dear students, in today's lecture, we will have discussion about vehicular ad hoc network. And as you can see, that this is the future of mobile computing, that we will have driverless or autonomous vehicles in our smart cities. In this diagram, you can see that we have different vehicles and they have their zones or range in which they can transmit data. Similarly, they can avoid any conflict with any node when it comes inside this range. So you can see in all these vehicles that they are equipped with the transmission technology, and then they can communicate with one another. So our today's lecture is about these vehicular networks, in which we will study that how these nodes can communicate with one another. So what is VANET? VANET actually stands for Vehicular Ad Hoc Network. And if we have a look, Vehicular Ad Hoc Network, it is the advanced form of mobile ad hoc network. And in these network, different types of vehicle actually communicate with one another. We have three types of communication here in these network. Number one is vehicle to vehicle communication. Here you can see, then vehicle to infrastructure communication, and then onward infrastructure to vehicle communication. In this diagram, you can see that we have a specific architecture for vehicular ad hoc network, in which RSU roadside units are deployed on the road, or on the highways, or on the subways at multiple points, and that these roadside units actually connect with the internet and with the infrastructure. So these RSU actually helps these vehicles that they can have connectivity with the internet, and they can also share with data with one another as well as with the infrastructure. Uh, so here you can see the detail of this roadside unit or your roadside infrastructure units, which is named as RSU. And these RSUs are equipped with onboard processing and wireless communication module. They actually provide the help for communication in the form of a backbone for these vehicular networks. Here you can have a look to the communication model, that is vehicle to vehicle communication and vehicle to infrastructure communication. So if we have a look to this diagram, this type of communication here between this car 1, 2, and 3 is vehicle to vehicle communication, while communication between this car and the BTS point is vehicle to infrastructure communication. These base stations are RSU, you can see, is connected through wire network with one another, and then onward they can have a fiber-based infrastructure for fast communication. So this communication where vehicle is communicating with one another is different as compared to vehicle communication with the infrastructure. You can also see that some vehicle can also uh, play the role of a forwarding node or a relay point, that they can provide access to faraway nodes to the main infrastructure or to the RSU unit. Here inside the cities, you can see that the nodes are communicating with one another. In city, we have actually different types of scenario. You can see here that here on this junction, multiple nodes will pass through this junction and they will move to different direction. So we should ensure that which vehicle is moving to which side or to which direction, and then they can coordinate accordingly. Similarly, on this junction, we might have some specialized camera or sensor nodes that they can look into the traffic density on each side, and then the signal may open for longer period of time for that side from where the traffic density is higher as compared to the other side. You can see here we have just one vehicle here on this side, while on this side we have five, six, seven vehicles, and they are waiting for this signal. So the signal will be working in coordination with the vehicular network infrastructure that it can work together. So what can VANET, our vehicular ad hoc network, provide? There's still a question that what is the main purpose of these network? So if we have a look, the first important thing is the warning for the vehicles, specifically if there is any lane sliding, if there is any damage to the road, if any bridge has been broken, or any vehicle is out of order and it's still standing on the road, then there are certain warnings to the vehicles which is coming in that direction. In many situations, if we have a look to this diagram, this is actually a curve where the node or the vehicle coming from backside cannot see this vehicle which is parked here because of some problem. So therefore, this vehicle is actually sending a warning message to those vehicle which is coming too fast from the backside, so they can slow down, and then onward they can take the other lane or the other track to pass this vehicle. So this is very important to convey or to share or to disseminate this information with all those vehicles which is coming from backside. If it's not like this, then these vehicles coming from back are too fast that they will not be able to control their vehicle here in this curve. So there is most possibility, or you can say the probability of accident or collision is very higher in this region if they don't disseminate this message. Here in this situation, you can also see in this junction, these two vehicles are coming from this side and from the other side, so they can collide here on this junction. So therefore, they actually inform each other that slow down because another vehicle is coming from other side as well. Here is another communication model. You can see that here is some sort of repulsive force. We have some sensors in these bumpers of these cars, and these cars directly communicate with one another that they should keep a safe distance from one another. Otherwise, if they are not following the rule to keep the safe distance, then there is possibility of collision as well. Here is another example. As you can see, the bridge is broken, and if you can have a look that a vehicle coming from this side or from the other side may not be able to see that the bridge is broken as they are moving from low side to the higher side, and the bridge is broken here. So therefore, it is important to deliver this information to other nodes which are coming on this side earlier, so they can take care of this bridge and then onward to find an alternative route to get their destination node. Here you can also see some traffic and road condition, as you can see a lot of congestion here on this side. So the traffic may be observed, and the decision should be taken based on the traffic condition on any next route or any route that should be on the list of the vehicle. So you can see here that in this congestion, the node will avoid to use this route for its final destination if there is any other option available. Here you can also see sometime there may be blockage because of the error in the system, or because of the problem with these vehicles. Or sometimes there may be a possibility that the vehicle can go out of order, such as these big trucks, and they actually block this traffic. We even can't move them very easily with the help of people. So therefore, there is a certain type of blockage which can increase the congestion in that area. Here you can also see over here that some nodes are coming from this side, and then they may collide with few other nodes coming from other direction. So this is possibility of the roadside unit as well as the vehicle to coming on that side to avoid these collision and inform these nodes that they should control their speed and should adjust or to stop their vehicle before that collision occur. Here you can see a rail track, and then onward the vehicle is trying to pass this rail track, though the bar over here is closed and the gate is closed here, and it didn't allow these vehicles to move. But because of some misunderstanding, the vehicle actually go on the rail track, and then there is an accident and collision between rail and this vehicle. Here are a few other examples in which the vehicles are actually in conflict with other vehicles. One important thing here is the smart street light control. We also had some research in this area. One of my master student has done some work on this. And in this situation, you can see that we have sensors in these lights. That is the motion sensors. And whenever there is no vehicle on the road, then automatically these lights will switch off. This is a model in which we can save the energy as well as we can save the electricity in different regions or in different cities. And whenever the vehicle comes and there is any movement, then onward the light on, and then after some time, when there is no mobility, then the lights will get off. So you can see here that we have one unified network connection between these road lights, IoT devices that are deployed here. Even here on the main hood, you can see that we have IoT sensor deployed. Here IoT sensors deployed, and then onward we also have the complete structure of this light given over here. So with the help of these devices, we can have this is the future of a vehicular ad hoc network, as there are some crises of energy in the world. So we are moving toward electric cars. And in that situation, charging these cars may take longer time. So for this purpose, they have proposed a new architecture to recharge these cars by introducing a recharging lane on the road as well. This experiment has already been done, and even recharging lane has been deployed in Sweden as well as in Denmark, and they are actually going to facilitate the people having the electric charge. What VANET provide, as we discussed earlier, it can provide safety, it can provide efficiency, similarly road and traffic condition, similarly road signal alarm. For example, if you are violating any rule, then it can inform you, and then onward, it can also provide local information about your interest, for example, from where you are passing. So what are the closest hospital, what are the closest shopping mall, or for example, if your car has any problem, then what local support is available in this area. So this is very important to know about these network. There is still possibility to do some research work in this area, as this area is still new, and there are still certain challenges in these vehicular ad hoc network, based on which it is a very interesting field to do the master thesis or your research work. And you can see here still the availability and mobility of these nodes, that how we can be able to control or ensure the availability. Specifically, if we can have the information about urban and rural scenario, then it becomes more challenging. For example, if you take the highway scenario, then it will be totally different from a road inside a city. Similarly, describe particular attack, what kind of attack is possible here on these vehicular ad hoc network, and how we can provide some solution to address these attacks. So security is by itself another threat for these networks. Specifically, if we are going toward the autonomous vehicle, driverless car, then how we can ensure the security. So here are certain security requirement for these network. Number one is message authentication and integrity, how we can ensure that the message received by this vehicle is authentic, and how we can ensure the integrity. Similarly, message non-repudiation, entity authentication, access control authorization, message confidentiality, privacy and anonymity, availability and liability of identification. So if you have a look to these requirements, it is obvious to think about, if you are receiving a message from some node, then you should know that this message is not altered by any node in the mid or on its way. The person who is actually sharing this message is an authentic user, and if even he is an authentic user, then it's fine. But either he has this authority that he should share this information, and then onward how to respect the privacy and anonymity of any node. So now moving toward these requirements one by one, we will have discussed them. Number one is message authentication and integrity. Here, message must be protected from any alteration. No one should do any alteration in these message on its way. Then onward, message non-repudiation, where the sender of a message can't deny having sent a message. No one should deny that he haven't sent this message later on. And we have different ways through which we can ensure the non-repudiation. Then the entity authentication, either the receiver is ensured that the sender generated a message and the receiver has evidence of the liveness of the sender as well. So this is that the user is an authentic user, and therefore we should trust and we should accept its message and then onward process it accordingly. Then access control, which determined locally by policies and authorization established that what each node is allowed to do in the network. So access control is that how much access do you have. Either you have access to your personal information, your own information, or to your neighborhood information, and similarly, which information you can share with other nodes as well. And the message confidentiality, which means that the content of a message is kept secret from those nodes that are not authorized to access it. So how to ensure this confidentiality, that anyone who is not part of this network or who is not authentic or authorized user, that he may receive this information. For example, if because of any problem, the information is received by any unknown user, then we should take care of its security as well. Then privacy and anonymity, you can see that in vehicular communication, we should not disclose any personal and private information of any user, and therefore we should respect the privacy of every user and provide them some anonymity. Any observer should not know any future action of other nodes, and anonymity may not be a reasonable requirement for all entities of the vehicular communication system. So sometimes even anonymity can be dangerous, because if any node is under uptake and he is sending a message or sharing message with the RSU or other vehicle, then the identity of that node is really required to take certain action against those attacks. Then onward, we have another requirement, that is availability, where protocols and services should remain operational even in the presence of faults, malicious, or benign. Even if there is any attack, if there is any flaw inside the network, still we should ensure that the system must provide the required services to the user. Then liability of identification. You can see that in vehicular ad hoc network, every user is registered, and user of vehicles are liable for their deliberate or accidental action that disrupt the operation of other node as well. So you have to follow these rules as regulations, and most of these regulations and rules are defined by the local governments. For example, you have the driving car, then onward, which vehicle you can drive, in which area you can drive, and then onward, have you done any violation of any traffic rules? So that is very important. Now we will have discussion about the system model, and if you can see in system model we have three important components. Number one is the user, which is actually the driver, then the network nodes, which is the vehicles, and then the authorities, which is the city authorities such as police or the city administration. Here you can see the vehicle and driver actually inside this car, and then onward it is registered by the city authorities. Then the RSU deployment by the government or the city authorities is also important. So where you are, how much you follow these policies and rules, and then onward you should have access to these network service. So the first important thing, as we can discuss earlier, that user is actually the owner or the driver or the passenger of the vehicle sometime. Passenger in case if we have a driverless car, then the passenger may be the owner of that vehicle. Then the network node, which is responsible to process for do the computational processing for this node, and then mounted on a vehicle or roadside unit, which ensure communication between the vehicle and the network infrastructure. Then onward, we have the authorities, which actually give these policies, which define the rules and regulation that how a node should be have, and what kind of registration should be done before bringing a vehicle or a driver on road, and then onward how it will be connected with the city infrastructure. So these authorities are actually public agencies or corporation with administrative power. For example, we have city or state transportation authorities. Now, in system model, if we have a look to the main operational unit of these vehicle and this infrastructure, RSU defined or deployed by the city government, we have a certain assumption that how this operation will take place. Number one is the authorities, which define the rule and regulation. As I discussed, that before bringing a vehicle on road, you must have the registration. Before a person who want to drive that vehicle, he must have the driving license, and he must have the license, or you can say that the medical condition should be that he may be able to drive this car. Sometimes you know that person may have the driving license, but he is not in senses, or he has some other problem, medical problem, so he is not allowed to drive at night, for example, if he has some side problem, or for example, if he has used any medicine because of which he is not in senses, then in case he want to drive in emergency, then still he has to inform the hospital authority or the city authority that because of that he is driving that car. So there might be some compulsion because of the medical conditions of certain drivers, though they have the driving license, but still they are not allowed to drive. Vehicle identification and credential. This is actually the node identification. Either your vehicle is registered, and if it is, then in which area you can drive. Infrastructure identification and credential, with which infrastructure it will connect, and then onward, and the infrastructure is also authorized to provide this services. Then user identification and credential, the driver, the passenger, and then user and vehicle association, how they are actually this vehicle belongs to this user, or this vehicle belongs to the user father, or to the user department, or to the user company, to the user employer, and so on. And what are the trusted component actually that can share information with that vehicle, and then onward the vehicle will take action accordingly. Here we have the authorities, as we discussed earlier, then onward the vehicle identification and credentials. And in this situation, we have the unique identity for every vehicle, and it is also verified with the help of public and private keys, that who actually issues this registration number, and then onward that the authority actually verify the credential of any vehicle. Here is the model of the new vehicle. You can see here that the vehicle was designed earlier, and there is on board unit over here in this car. So here is the abstract view of a vehicle in a secure vehicle communication system, where we have unique identity, then credential and keys, then CPU module, and then wireless communication module that is deployed. You can see here this is a Mercedes car, and it is equipped with all these required components that can help the authorities, that can help the registration, and that can also ensure that this node is an authentic user. So here is the infrastructure and identification and credential, which uniquely identify the user, and then after providing certain information, you can communicate with other nodes. And this is actually the key. You can see here in this figure, or in this picture, that he has the key, with the help of which he can first recognize himself as an authentic user of this network, and then onward, after recognition of that node as an authentic user, he will be able to communicate, and he will be considered as a trustworthy node, and to provide services to other nodes, and then onward to also forward, also share, also receive information from other nodes on the road, or from the RSU, from the network, as well as to share with other nodes as well. Another important thing, that we have different types of vehicle on the road. So how we can categorize these vehicles? What are public vehicles actually? So public vehicles are actually vehicles that belongs to the government, and that is, for example, police. We also have the air police, and then onward the public transport system, and sometime even in some situation we have the emergency vehicles, such as ambulance, such as firefighter vehicles, or such as emergency task forces in many areas. So these are actually the public vehicles which belongs to the government, or public for public safety. So user and vehicle association, as we discussed earlier, that who is the owner of this vehicle, either the driver by himself, or the passenger is actually the owner of this vehicle. Now, we can assume that only one user can operate a vehicle at a time. The vehicle can be registered on the name of one user, who can be a driver, as we discussed earlier as well, that sometime a person who is driving a car, and the car is registered actually on his father name, or on the name of the employer, or on the name of the company, or on the name of department. And then we consider the trusted component, which is very important, that how much trust you have on information that is delivered by these components. So nodes are actually equipped with trusted component, built-in hardware and firmware, and these trusted component actually enforce a policy on the interaction with the onboard software. As we discussed on the Mercedes car, where we have already a board deployed on that vehicle. So how this vehicle will get information, and it will share with other nodes. How much access this node will have to information, as you can see here, that access to any information stored in trusted components and modification of their functionality can be done only by the interface provided by that trusted component. So in this situation, if we go to the autonomous vehicle, unmanned vehicle, the car will not be in control of that driver or that user, and many stages. So it will be controlled by the authorities, and they can stop you anywhere. They can divert the direction of that vehicle wherever they want. So this is also a good model, but another important thing is that you will lose the control on these vehicles as you have today. Communication model, you can see that we are using wireless communication and ensure connectivity between vehicles, among vehicles, between a vehicle and infrastructure, and then infrastructure to vehicle. Though the speed of these vehicles are very high, are very fast, and they are continuously changing their location. So therefore, there is a bit challenging task engaged over here, that the position is actually changing from time to time as the node is moving from one location to another location. They are even continuously changing their RSUs as well. So we mainly focus on the data link layer because of this mobility. So you can have a look over here that links that actually helps us to communicate between different nodes. They can be reestablished once you change the RSU. So links are either up or down, and their state doesn't change faster than the transmission time of a single packet. Similarly, ensure the network connectivity, that the node should be connected with the RSU as well as with one another, so they can share data. Packets are delivered across an uplink with a maximum link delay T, or they are not delivered at all. For example, if you are in a zone where you have no access to the RSU, or sometimes you might be in an overlapping region, so in that situation, you may miss the traffic. Communication across the network is dependent on availability of sufficient resources. And you can see here in this diagram, there are too many vehicles, and everyone is trying to get the resource and pass through this junction. Here you can see in this picture as well, that everyone is trying to get the resource and get out of this congested area. So if we also have a limited bandwidth everywhere, then same is the case with uh, the road on which the vehicle is moving from one location to another location, which is shared between multiple nodes. So sometime as the link is shared, so the contention may raise over here, and the bandwidth can fluctuate with time to time. Sometimes we have the unevenly distributed bandwidth, which may cause some more problem, and the link become congested as quickly as possible. Communication radius, as we have seen on the first slide as well, that this radius actually represent the area of this node in which its signal will be available. And then any node coming in this area or in this radius will be intimated that a collision may occur if we move onward. So this radius may vary from time to time, and it also vary based on your position. Either you are in cities or you are in a remote area. So there are different classes of nodes, and they may operate with different radius, which actually define the zone of these nodes. A multi-domain and high volatile environment is actually there in vehicular ad hoc network, because nodes are not bound to administrative and geographic boundary. Therefore, any two or more nodes communicate independently. And therefore, you can see that multiple nodes communication may cause some problems sometime. Frequent broadcast communication, as you know, this is the traditional way of these wireless network, that they send broadcast and they share information with other nodes. So sometimes there is possibility that some irrelevant nodes may receive these messages. And these messages are transmitted either periodically or based on some triggered event. For example, if there is any accident, any problem, any congestion on the road, then the nodes actually send information about that status. Time sensitive communication, in many cases, we need real time communication, and therefore the information should be delivered as early as possible. So the nodes coming from backside may take certain action. For example, if a node is coming from backside and there is an accident or the bridge is broken, then we must inform the nodes which are coming from the backside. Then we have the adversary model, and we can have a look that what kind of node we have uh, here in this vehicular ad hoc network. Either we have the correct nodes are benign, faulty, or adversely. Either they are internal or external adversaries, either that is from our own network or from some other network. What kind of adversary they are? Either they are active or they are passive adversaries. You can also have a look to this faulty process, which is faulty, is not always malicious. So sometimes the problem may occur, and you can see also in this screen. If this is the first time you have seen this stop error screen, restart your computer, and if this appear again, follow these steps. So in situation of a vehicular ad hoc network, specifically if we are going for driverless car, then we will face these faults, as well as there will be some sort of hacking of these nodes as well. So the people or the hacker can get control of your vehicle, and you will not be able to revert it back. There are some design principles that how we can design these network. One of them is default network access, that how much access you can give to a node, locality and timeliness, visibility of event, mandate, uh, and then accountability, vehicle autonomy, separation of privilege, non-flammability. These are different principles that you should be in mind before designing of these vehicular ad hoc networks. So that's end of this lecture. But let me explain it a little bit that this is the future of mobile computing, that the vehicle will move from one location to another location without any driver. They will self control, they will have a self control mechanism. They will communicate with one another, communicate with infrastructure. And for example, it brings a new venue for research to our student and faculty members as well. And that is one of the important component of smart cities, smart road, and smart vehicles. Then onward, we have some variations based on the scenario. Either we are taking an urban scenario or rural scenario, because the junction inside a city and specifically a very busy city will be different from a highway scenario. On highway, you know that you have junctions after 10, 20, or 25 kilometers, while inside a city you have junction after zero point 0.5 kilometer or even less than that. After 3, 4, 5 blocks, you have a junctions, you have signals, and vehicles are standing there waiting for their turn to pass through that signal. So the communication magnitude, the number of users, the number of vehicles may vary from time to time, and that's why we actually adjust the zone or the range, the radius of these nodes accordingly. If you are coming inside a congested area, then definitely the radius will go down. While if you are going in a suburb area, in a remote area, then the radius of the nodes goes down. Nodes goes up, and you will increase it. If we can have a look to the cellular network in remote area, this is almost 35 kilometer, while in cities it is even less than 1 or 2 kilometers. So this is all about our today's lecture. And if you have any question, you can ask. So thank you so much, and